Hi guys, here is a second video for Pythagorean theorem. This video is going to talk about finding the distance between 2 points on a coordinate plane using the Pythagorean theorem and some word problems. All right, so let's get started. Finding the distance between 2 points on a coordinate plane. Okay, so what I'm going to do first is I'm going to plot the two given points. So it says P is at -5, +3. I'm going to label it, and Q is at 3, -4. So I'm going to plot that. All right, I'm going to connect my points with a line. And it wants to know what is the distance between those 2 points, okay? So when I'm looking at my graph here, I can't just count the distance, because these are on a diagonal. It's not a whole unit. So I can't, whoops, I didn't mean to do that. I can't just kind of count the diagonals or anything like that. So what I am going to do is I am going to create a right triangle. Okay, so I'm going to go down to where Q is, and then I'm going to go over to where Q is. All right, and now I have a right triangle. And what I can do with my right triangle is I can easily count this distance right here. I can count the boxes. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 units. I can also count the distance I went down from P to get to Q. 1, 2, 3, 4, 5, 6, 7 units. So this is 7 units, okay? So now, since I know, remember these are the two legs of the triangle, I can use the Pythagorean theorem, a squared plus b squared equals c squared. I know the length of the two legs, so I can plug 7 in for A, 8 in for B, and I don't know C, the diagonal. All right, now I'm going to solve this using my Pythagorean theorem. So 7 squared is 49 plus 64 equals c squared. And when I add 49 and 64, I get 113. Oops. And now to get c by itself, I'm going to take the square root of both sides, and that will give me the length of my diagonal, or c. And let's round this to the nearest tenth. So I could say that c is approximately, this is going to round to 106 units. And that's the length of C. Okay, let's try another one. All right, so we have, we want to find the distance between F and G. So F is at -3, -2, and G is at +4, 5. All right, so I want to find the distance between F and G. All right, so I'm going to do that by creating the sides or the legs of a right triangle. All right, so now I can find the length of this side by counting the boxes and the length of this side by counting the boxes. So I go over 1, 2, 3, 4, 5, 6, 7 units. And I go down 1, 2, 3, 4, 5, 6, 7 units. Okay, and so those are my legs, and I'm looking for the hypotenuse, or looking for C. So I'm going to write my formula, substitute in 7 and 7 for the legs, and looking for the hypotenuse of C. All right, 7 squared is 49. 49. When I add 49 and 49 together, I get 98. And now the opposite of squaring, remember, is the square root. So to get c by itself, I'm going to do the square root of both sides. And the square root of 98 is 9.89. Let's round this to the nearest tenth again. So I can say c will be about 9.9 units. Okay, so those are two examples of finding the distance between 2 points using the Pythagorean theorem, creating a right triangle, and then using your Pythagorean theorem to find that diagonal. Okay, a couple of word problems. So the big part in these word problems is you are going to want to draw a diagram, okay? Your diagram is going to allow you to see the different sides of the triangle and what you know. All right, so let's look at number 1. It says that the leg of a right triangle. So I'm going to stop because I'm going to draw my right triangle because I know I'm looking at a right triangle. Okay, so the leg, one of my legs, is 23 inches long. So I'm going to label this side 23. And the hypotenuse is 29.2. So here's my right angle. The side across from it is the hypotenuse. And I know that this is 29.2. What is the length of the other leg? So I'm looking for this side. Round to the nearest hundredth. All right, so since I'm looking for a missing side of a right triangle, I'll use my Pythagorean theorem. I'm going to plug in what I know. Do I know one of my legs? Yes, 23. Do I know the second leg? No. I'm going to make that x. Do I know the hypotenuse? Yes, 29.2 squared. All right, so now I'm going to simplify this. So I get 529 plus x squared equals 852.64. So now I have to get x by itself. So I'm going to subtract 529 from both sides. And I get x squared equals 323.64. Not done yet because I don't have x by itself. I have x squared. So I'm going to do the square root to get x alone. And the square root of 323.64, whoops. 323.64 equals 17.989. It says round to the nearest hundredth. So when I round this to the nearest hundredth, I can say that x is approximately 17.99 inches long. Okay. All right, here's another example. All of the telephone's poles in a certain area are 30 feet tall. So 30 feet tall. The distance from the top of one telephone pole to the base of the next telephone pole is 50 feet. What is the number of feet in between the poles? Okay, so I know that the height of the telephone poles are 30 feet. So this pole is also 30 feet. Okay, I see here that where the cable comes down, the pole, and the ground, that makes a right triangle. This cable is my hypotenuse of the right triangle. And I am looking for a leg. Okay, so now that I've figured out my triangle and all the parts of the triangle, I know I'm looking for a missing piece. So I'm going to use my Pythagorean theorem. All right, so C is 50. One of my legs is 30, so I'm going to put 30 in for A. And I'm looking for that second leg. Okay, got to simplify this. So 30 squared is 900. 50 squared is 2500. I got to get x by itself, so I have to get rid of that positive 900. And I'm going to do that by subtracting 900 from both sides. 2,500 minus 900 is going to give me 1,600. I'm going to take the square root of both sides. And x, the square root of 1,600, is going to be 40. So x equals 40 feet. Okay. Next example. Okay, Joe placed a ladder so that it reached the window 15 feet above the ground when the foot of the ladder was 5 feet from the wall. Find the length of the ladder, round your answer to the nearest tenth. Draw a picture to help you. Okay, so let's say this is a house, and here is the window. Okay, there's going to be a ladder that's leaning up against the house to reach that window. This is the ground. All right, it says that Joe placed a ladder so that it reached a window 15 feet above the ground. So this is saying that the window, this ladder reached the window, and the window is 15 feet above the ground. So the distance from the ground up to the window is 15 feet. When the foot of the ladder was 5 feet from the wall. So here's the foot of the ladder, and it's saying that this was 5 feet away from the wall. Find the length of the ladder. And this, my labeling makes sense because it's telling me to find the length of the ladder. And in my diagram, I see a right triangle here, and the only piece that is missing is this side, which is the ladder side. That's what I'm looking for, that length of that ladder. Okay, so I'm going to use the Pythagorean theorem. I'm going to plug in. I know here's my right angle. The house and the ground make the 90-degree angle. I know my two legs. So 15 squared plus 5 squared, and I'm looking for the hypotenuse, the ladder. All right, 15 squared, I get 225. 5 squared is 25 equals x squared. All right, so now I'm going to solve for x. So this time I'm combining on the left. I get 250 equals x squared. I have to get x by itself, so I have to get rid of that squared. I'm going to take the square root of both sides, and then the square root of 250 is 15.81. It says round to the nearest tenth, so I can say 15.8 feet is the approximate length of x, the ladder. Okay. All right, I'm going to do 2 more examples. Okay, number 4, it says Ryan and his uncle left the shore in their boat from point A and continued on the course for 75 meters until they reached B. So from A to B is 75 meters. Okay, after fishing there for a while, they made a 90-degree turn, so 90-degree turn, and continued 125 meters to point C. So continued this distance, which was 125, to get to point C. The diagram shows the course they took and the locations of 2 different fishing spots on the lake. What is the shortest distance they will travel from point C to get back to point A? Round to the nearest tenth. So to get from C to A, the shortest distance would be that straight route going right back. Okay, so they left here, they went to B and fished, went to C and fished, and now they want to get home as quickly as possible, and that would be the straight route home. So we want to know, well, what is that distance? Okay, here's your 90-degree angle. The distance across from it, or the side that's across from it, remember, is your hypotenuse. So I'm going to use my formula. I'm going to plug in, I know my 2 legs, 75 squared, 125 squared, and I don't know the hypotenuse. Okay, so I'm going to solve for that. 75 squared is 5,625. 125 squared, 15,625 equals x squared. Okay, so now this time I've got to get x by itself. So I have to combine what's on the left side first. I'm going to add 5,625 plus the 15,625, and I get 21,250 equals x squared. I still don't have x by itself. I have x squared. So to get rid of that squared, I'm going to take the square root of both sides. So I end up with x, and it says round to the nearest tenth. So I put that in my calculator. The nearest tenth means that this is going to bump up to 145.8 meters is approximately the distance from A to C. Okay, number 5. It says Mr. Edwards is unloading the contents from his moving truck. The deck of the truck, which is here, is 3 feet above the ground. So here's the ground. Oops, that's not a very nice straight line. Let's use this little guy. So there's your ground. From the deck of the truck to the ground, that distance is 3 feet. It's 3 feet above the ground, and he's using a 9-foot ramp. So we have a ramp that's going up to the deck of the truck, and it's 9 feet. How far from the truck will the ramp extend along the ground? So how far from the truck does this ramp go? So we're looking for this distance right here. Okay, this height of the bed, or the deck they call it, and the ground make your 90-degree angle. Okay, so this 9 feet or a ramp will be the hypotenuse. So I'm going to use my Pythagorean theorem, and I'm going to substitute in 3 for one of my legs. I don't know the other leg, and 9 will be the hypotenuse. So I can simplify this. 3 squared is 9. 9 squared is 81. Now I have to get x by itself. So I have to get rid of this positive 9. So I'm going to subtract 9 from both sides. I get x squared equals 72. Now I have to get rid of that squared. So I'm going to do the square root of both sides. I get x by itself. And now the square root of 72. It says, now we're going to ignore, I should have deleted this. We're going to ignore the simplest radical form. Okay, let's round to the nearest tenth. All right, so x is going to be approximately 8.5 feet. Okay. All right, attached or to go along with this is a worksheet that I would like you to complete using Cami and submit it by the end of the week. All right, if you have any questions, feel free to email me.